Hello, Matthews Gatos here. Welcome to section 6.3, adding and subtracting rational expressions. Before I get into that, I want to review multiplying and dividing. So in this question here, I have an expression a times b divided by c, which in lowest terms can be written as x plus 4 over x plus 3, where x cannot equal to positive and negative 3. So I want to find possibilities for a, b, and c. This is a coding question. I would recommend pausing the video, trying this question, there are multiple answers, and then come back and see how you did. So I'm going to start with my restrictions. So looking at my restrictions in the denominator, I have a restriction that x cannot be positive and negative 3, which means I have factors of x plus 3 and x minus 3. Now in my final answer, you'll notice I don't have a factor of x minus 3. So that must mean that my original expression has a factor of x minus 3 because those would cancel. My final answer also has x plus 4 in the numerator. So I know that could be one possible original expression, because if I were to cancel, then I would end up with x plus 4 over x plus 3. So let's look at that. This denominator would be c. Now, if I factor this difference of squares, I know one option for c could be option 9. Looking at a and b, I can see that this could be a possible option for a, making a code 1, and then x plus 4 could be a possible option for b, which would be option 5. So one possible code would be 159. But let me show you just another one. If I look at the option for c above here, notice that x squared minus 9 is doubled, so I know that this really factors as 2x minus 3, x plus 3. So let's add on a 2 there. So if that was a possible denominator, that means I need a factor in the numerator that is also doubled. So looking at my options, I could choose, for example, option number 4, which is 2 times x plus 4. So throw a 2 on there. So another possible code would be 4 for b, 8 for c, and let's keep a as 1. That would be another possible code. So try figuring out some other codes and then check to see if they work. So in this lesson, we're going to look at adding and subtracting rational expressions. But I always like to go back to numbers first. So let's go back to junior high when we first were introduced how to add and subtract fractions. So my tip for you is when the denominator is the same, keep the denominator and either add or subtract the numerators. Don't make this mistake. Don't add the numerators and add the denominators. That's not right. So because the denominator is the same, I can keep my denominator as 8 and add my numerators 1 plus 5, which is 6. Then I put that into lowest terms. Always reduce your fractions to 3/4. Let's look at the next example with subtracting. So again, we're not going to make that mistake of 3 take away 1 over 4 take away 0. We're going to keep the denominator the same and subtract the numerators, which is 2/4, or in lowest terms, a half. So we can see with numbers that it wouldn't make sense to add and subtract the numerators and denominators together. So let's not make that mistake when we use monomials. Let's try this example. I have x plus 1 over 8 take away 3x minus 2 over 8. So first thing, let's talk about the restriction. There is no variable in the denominator, so there's no restriction. So my tip for you here when we're subtracting, especially when we're subtracting a binomial, is to make sure to use brackets to subtract the entire numerator. So I place it over my common denominator of 8, and I put brackets around because I want to subtract term by term. I want to subtract a 3x, and I also want to subtract a 2, which really makes it negative 2. So when you subtract a negative, it becomes a positive. I often get asked, if 2 negatives make a positive, does that mean that 2 wrongs make a right? I don't really think it works that way, but please remember when you subtract a negative, it becomes a positive. And then all I have to do is group my like terms. So x take away 3x is negative 2x, 1 and 2 is 3, and that's all over 8. So I always like to do the check. So putting that into my calculator, you can see original in Y1, answer in Y2. And because Y1 equals Y2 in the table, that's where the check always happens, I know I did this correctly. A common mistake, don't be a homer and make this mistake. When you subtract, a common mistake that I see is just subtracting the first term and leaving the second term as is. So that is a common mistake with subtraction. So anytime I do subtraction, follow my tip, use brackets to remind you to subtract the entire numerator, not just the first term. Okay, let's look at another example. So I want to state my restrictions. I have 2 factors in the denominator, which means I have double trouble, 2 restrictions in total. So my restrictions are that x cannot be -1 or +2. So now that I've done that, I'm going to group it as one fraction with the common denominator, and I'm even going to use brackets for adding just to be sure I don't make any mistakes. So keep my denominator the same and then add. So I have 2x squared. I'm going to add -5x to 4x and add a -6. Then what I'm going to do is factor. I always like to factor if it's possible, just to see if there's anything common to the numerator and denominator to simplify. Okay, so I'm going to do a 2x and x. I am going to do a 2 and a 3. And then this will be negative, this will be positive. I always just want to double check to make sure I did that correctly, which I did. And I can see, good thing I did factor, a common factor of x minus 2. So it looks like my final answer is 2x plus 3 all over x plus 1. But I'm never 100% sure until I check in my calculator. So original in Y1, answer in Y2, the check always happens in the table, and with the exception of the non-permissible values, I see that I'm correct. Okay, let's look at what happens when the denominator is not the same. Of course, this is when it gets a little trickier. So when the denominator is not the same, you want to find the lowest common multiple to create equivalent fractions. To use that lowest common multiple to add the fractions. So don't make the mistake of adding the tops and adding the bottoms. That's wrong. I need to find a lowest common multiple. Now the lowest common multiple between 3 and 7 is 21. So what I'm going to do is create equivalent fractions with 21 as the denominator. So to go from 3 to 21, I have to times by 7. So I also multiply the numerator by 7. Now, if you look at this, 7 over 7 is 1. I haven't changed the value of the question because all I've done is taken 2/3 and multiplied it by 1. Look at my next one. To go from 7 to the common denominator of 21, I multiply top and bottom by 3. And 3 over 3 is 1, so I haven't changed the value of the question. So what I really have is 2 times 7 is 14, plus 1 times 3 is 3. Keep the denominator the same and add the numerators. Let's try subtracting 1. So again, don't make that silly mistake of subtracting the tops and the bottoms. We need a common denominator. So the common denominator between 8 and 2 is just 8 itself. So the first fraction stays the same. The second fraction is multiplied by 4. And again, notice I did it to the numerator and denominator, and 4 divided by 4 is 1, so I haven't changed the value of the question. So this now becomes 5 over 8, take away 1 times 4 is 4 over 8. Keep the denominator the same, subtract the numerators, and you're done. So let's try that with some polynomials. When I add and subtract rational expressions, again, I want to find the lowest common multiple. And the only way to find that is by factoring. So I'm going to factor just the denominator. Now remember that the lowest common multiple will be one of each factor, and it will be the highest exponent. So if I have an x, for example, and an x squared, well, common denominator is an x, but it would be an x squared. Then what I want to do is change each fraction to an equivalent fraction with the lowest common multiple and state my restrictions. Once I'm done that, I can expand and group like terms in the numerator, place it over the denominator, and factor the numerator if possible, because we're looking to see, is there anything that can cancel? Leave your answer in factored form, and my favorite step, remember the check. So let's try. So nothing to factor there because it's just a binomial and a binomial. So let's find the lowest common multiple first. So lowest common multiple between each of those factors is actually going to be one of each. So my lowest common multiple will be x plus 3 and x minus 3. Let's talk restrictions. I have two factors, so that's double trouble. Two restrictions. So looking at those, I know that x can't be positive and negative 3. Now let's change it into a common denominator. So we're going to use our lowest common multiple as the denominator. So looking at my first fraction, I have an x plus 3. So I'm going to multiply top and bottom by x minus 3. Again, when I do that, I'm not changing the value of the question because I'm doing it to both. So now the denominator matches, and in the numerator, I have 1 times x minus 3. In the next one, I have the x minus 3, so I have to multiply top and bottom by x plus 3. Now, because this is a binomial, I need to apply the distributive property. And now I'm ready to combine it as one fraction with the lowest common multiple. So I have an x squared, I have an x, a 3x, and a 2x, so altogether 6x. And I have a negative 3 and a positive 6, which is positive 3. Now that can't be factored, so I can't go any further than that. So this would be my final answer with the restriction that x can't equal positive and negative 3. Again, I always want to do a check. Original in y1, answer in y2. The check always happens in the table, and I see that I'm correct. Okay, let's look at this one. So I do have to factor the denominator. So I know factoring the denominator is p minus 1, p plus 1, which is a difference of squares, and then p minus 1 can't be factored. So let's look at the lowest common multiple. Lowest common multiple of p minus 1, p plus 1, and p minus 1. Well, it's just going to be one of each factor. So I don't need two factors because the p minus 1 is counted and accounted for in each. Let's talk about the restrictions. So I have two restrictions, two factors, so double trouble. P plus 1 and p minus 1 can't be 0, so that means my restriction is positive and negative 1. So let's come up with the fraction with the lowest common multiple. Well, the lowest common multiple is the denominator of the current first fraction, so leave the numerator alone. In the second fraction, I have a p minus 1. I'm missing a p plus 1. So I will multiply top and bottom, to be fair, by p plus 1. So I have 3p plus 3. So now we can combine it as one big fraction with the common denominator, and I'll have 3p plus 4 and 3 is 7. That can't be factored, so that'll be my final answer, which of course I always check in my calculator, and you can see original in y1, answer in y2. They are equal in the table, so I know that is my final answer. Okay, let's try another one. So for this one here, I'm going to factor my denominator first. So factoring my denominator, I end up with x plus 1, x minus 1, difference of squares, and then I factor the trinomial. So as soon as I've done that, I can look at my lowest common multiple. So my lowest common multiple for all of that is just going to be one of each factor. So it's going to have 4 terms in it. So before we talk about what the lowest common multiple is, let's do our restrictions. So since I have 4 factors in the denominator, I have a Tim Horton restriction, commonly known as the double-double, because I have 2 restrictions in each. So putting that all together, I'm going to have restrictions of positive and negative 1, of 2/3, and of 4. We can put those in numeric order from smallest to biggest, and that would be my restriction. Now, looking at that lowest common multiple, that's a little bit ridiculous. We have 4 factors. So my tip for you is, whenever the lowest common multiple has too many different factors, I bet if you look at the numerator, you might be able to simplify the fraction. So let's do exactly that. So over here, I'm going to do it down here. Over here, what I'm going to do is I'm going to factor the numerator and denominator just to see if I can simplify it a little bit further. So in the numerator, I have 2, a GCF of 2, over x minus 1, x plus 1. And then I have a difference of squares. So 3x minus 2, 3x plus 2, all over my denominator, which was 3x minus 2 and x minus 4. Okay, so looking at this, I can see, yes, there is something I can simplify. Common factor of x plus 1, common factor of 3x minus 2. That is a lot more manageable to deal with. So let's deal with our simplified fraction over here. So have the restrictions from before, and I have now a simpler denominator, which is x minus 1 and x minus 4. There should be a minus. So my lowest common multiple is x minus 1, x minus 4, one of each. So let's change our fraction to the new common denominator. In my first fraction, you can see I'm missing an x minus 4. So I multiply top and bottom by x minus 4 to be fair. In the second fraction, I'm missing a common factor of x minus 1. So I multiply top and bottom by x minus 1 to be fair. So now that I've distributed it in, I can add this with one common denominator. Okay, so I've got a 3x squared, 2x, and 2x is 4x. Take away 3x is 1x, and then negative 8 and negative 2 is negative 10. Okay, so I always want to look to see, can I factor that further? And I believe I can. So I have x minus 1, x minus 4. And then I go ahead and factor this one here. So I'm going to put the 2 here and the 5 here. So this will be positive and that will be negative. I always just stop to check to make sure I did that correctly, and I did. Now, in this case here, there's nothing to simplify, but I always want to factor just in case there is something that I can simplify a little bit further, because factored form is simplest form. So let's do our check. Original in y1, answer in y2. Check always happens in the table, and it looks like I'm good to go. Okay, last example. Let's look at this one here where we're combining adding and dividing in one question. So again, the very first step is to factor. Factor your denominator. Once I've factored my denominator, I can look at my non-permissible values, at all of my restrictions. So remember, I always have restrictions in the denominator, but because I'm dividing, I also have that new restriction in the numerator. So you can see all of my restrictions there. Let's put them all together. I have x can't equal 1, negative 3, and negative 2. So let's put that in numeric order like that. So there would be my final restriction. Now, my tip for you, remember, when you have more than one operation, you want to follow BEDMAS. So following BEDMAS, I have to do division first. So remember, for division, you keep change flip. So the 1 over x minus 1 stays where it is. And I'm adding. Now I do my division part, which is the keep change flip. Let's look if I can simplify this. I have an x plus 2 that cancels, and an x plus 3 that cancels. So it looks like I'm left with 1 over x minus 1 plus x minus 1 over 1. So let's finish that question on the next page. So over here is my new expression, my simplified expression, with my original restrictions. So since I'm adding, I do need a lowest common multiple. So the lowest common multiple will be one of each factor. I technically don't need to write down 1 because 1 is a factor of every number. So let's create a fraction with the common denominator of x minus 1. The first fraction already has a denominator, so the numerator stays the same. In the second fraction, I will multiply top and bottom by x minus 1 to be fair. So x minus 1 times x minus 1, x squared minus x plus 1. So now I'm ready to combine it as one fraction with the common denominator. So I'm going to have x squared minus 2x, and 1 and 1 is 2. Because that can't be factored any further, that would be my final answer. So again, always go to your graphing calculator to check original in y1, answer in y2, and you can see in the table that it matches. So when it comes to adding and subtracting, equivalent fractions are the key. And I understand equivalent fractions have the same value, but I gotta tell you, the ones on the right feel like you're getting more bang for your buck. I couldn't agree more. You guys can go on and do your practice questions, check the solutions on D2L, and then go on to do your textbook questions. So I hope this video helped, and I look forward to seeing you for the next one.